This is the moment your game actually gets scary. In this video, we're adding one of the most iconic elements of Five Nights at Freddy's to our game, the jump scares. Your animatronic will jump out, screaming in the player's face, grab them, and kill them. We're going to do this in two different ways. The first is the way Five Nights at Freddy's does it. We're going to take renders created that are high quality from our game and then overlay them on our viewport. But don't worry if you don't have access to high quality 3D renders, you can use your own drawings. We're going to take an image that my son created, cut it up, load it into Unity, and then animate it so it looks like it's jumping out at you. Whichever method you decide to use, by the end of this video you'll have a jump scare animatronic attacking you. Creating the animatronic art. Before we jump into Unity, let's look at what a Five Nights at Freddy jump scare is really composed of. First is that we render things on a single plane. We're dealing with pre-rendered 2D images in this case, and we're basically playing an animation. They're not the full 3D models you'd see in a real-time rendering engine. Then, in some situations, we have a camera shake or a jolt. Usually when the animatronic is grabbing you, you'll notice the background shake violently. These jump scares are usually very short and violent, usually 1 to 2 seconds in length max, and you only see mainly the head area and a jaw that's attacking you. And this is important, because if we allow the player to see the animatronic for too long, they're going to get desensitized to it. They're going to get accustomed to it, and it's not going to be scary anymore. Of course, we need a crazy scream effect for our animatronic, because that's like 90% of what scares you. The visual is okay, but really it's that loud, piercing sound that really gets you. With all that in mind, let's go ahead and jump into two different ways to create this effect. So we're either going to do this with pre-rendered images, or we're going to create what's called a sprite sheet and bring that into Unity using a custom drawing that you can make. My oldest son was nice enough to draw me this picture you see here of Thin Rabbit. Now I also took that image and loaded it into ChatGPT, and after several prompts I was able to create this pretty interesting looking rendering of what this might look like in a more realistic setting. For method 1, I used my Foxy animatronic model that I had created for my old Five Nights at Freddy's series. If you want to know how to create it yourself, you can go back to videos 71 through 80 in the series and watch me make the entire thing. I loaded my character into Maya, did a lot of updating, retweaking, and regrouping, reassigned materials, and shortly I had an animation that I kinda hated. It reminded me too much of a flailing Muppet going side to side, almost like a crazy Kermit the Frog. So the next morning I woke up and decided to create an entirely new one from scratch, this time having the animatronic rise up from the bottom, grab a hold of you, and shake you violently. I rendered out all the frames using Arnold inside of Maya to render 4K images, and I quickly realized how stupid that was. Rendering out all those images at 4K, doing 120 frames a second for just 2 seconds of animation ended up being a lot of data. I went ahead, lowered the resolution down to 1024 by 1024, and rendered out every other frame, with the idea that it might make it a little bit more jerky and kind of animatronic-like. Now for method 2, which is probably what most of you are going to be doing, we're going to cut up a drawing that you're going to scan or photograph into your computer. We're going to take that image inside of Unity and create a sprite sheet, which allows us to cut it up into different parts. Each of those parts will be a different game object that we can transform, either translate, rotate, or scale. As usual, I'm working with Photoshop because that's what I'm comfortable with. Go ahead and take a few minutes and follow the same workflow that we covered in a prior video, where we loaded in a background image and edited it to be used inside of Unity. Adjust the levels and the lighting, retouch the parts that might be broken or didn't scan so well, and just generally clean up the image. If it was a black and white image, go ahead and take some time to add some color. I then started to separate the various parts, cutting at the joints of the drawing. This is going to end up being a trial and error situation, and you're going to find mistakes and flaws in your drawing. Just remember to have some patience with yourself during this process. The first time you create something will not be perfect. What you should be mainly focusing on is getting the head, jaw, torso, arms, and legs separated into separate parts of the image. You want to space them out so that each one is kind of within its own rectangular box, and there's no intersections of those boxes. This is going to make it easier inside of Unity to cut things up into our sprite sheets. When you're satisfied, you can go ahead and save this out as a PNG file. Just make sure you have transparency enabled and you've actually removed all the background elements from your image so we can see through the animatronic when it jumps out at you. Remember, all of the assets you're going to be seeing in this video are available to anyone on the creative tier on my Patreon website, so you can always follow along with those assets. Setting up the animatronic inside of Unity. Go ahead and create a new folder inside of Unity. and name it Jumpscares. I made 2 child folders, one for my Foxy animation, which is going to use this pre-rendered pipeline, and the other called Thin Rabbit, which is what my son decided to call his animatronic that we're going to be using the Sprite method for. For Foxy, I have a Foxy Frames folder where I drag and dropped all the frames that I rendered out. For the Thin Rabbit, I created a folder called Sprites where I dragged and dropped in all of my son's sprite sheet assets and the version that ChatGPT created for me. We're going to be building off the same canvas user interface we made in our prior videos, the same one that holds our map, cameras, and buttons. We're going to be covering the 3D rendered version first. Please don't jump ahead because we're going to be doing some things like setting up an animation as well as audio sources that are critical if you're going to be doing the Sprite version as well. Make sure all the images that you dragged and dropped into your project for this pre-rendered version are set to texture 2D. If you had set up your project to be a 2D workflow, by default they might have been set to sprites. As mentioned, we're working from our prior video, which already has a canvas user interface inside of our scene. If you don't have one, go ahead and add it now. Go ahead and add a user interface image to your canvas and call it JS_Foxy. JS stands for Jumpscare. This is going to hold all of our logic for controlling the animatronic and turning it on and off. Now add a UI raw image to JS_Foxy as a child object and name it Visual. Set the texture to one of your pre-rendered images to figure out the size. This means you're going to have to drag and drop one of those images you put in onto that inspector and then move it around. Play with the position and scale of your animatronic until you get something you enjoy. Now it's time for us to create our script. Go ahead and right-click, create a new Jumpscare sequence.cs file. Attach it to the Jumpscare_Foxy game object that you created. If you want access to all these scripts without having to type anything yourself, you can go to my website at www.gleecakes.com and copy and paste it into Unity. Now let's take a minute and briefly go over the script. We have several variables that are exposed, that is, they're made public. The first is our raw image, the scare image. This is a reference to the raw image that you created on the user interface that we'll be putting our texture onto and swapping it out to make it look like it's an animation. Then we have an array of texture 2D objects. These are going to be every single frame that I rendered out of my Foxy 3D animation, drag and dropped onto that element. We then have a frame rate, which tells us how quickly to move from image to image in our texture array. Then we have the option to repeat, which I set by default to 1. This allows you to repeat the animation. So if you created a sequence that's too short, you could add in 2 or 3 and it will keep repeating this that many times. Then we have an animator called camera shake. This is going to be set up later, but it allows us to trigger to shake the background of our image. Now we have 2 private variables. First we have our audio source, which is going to control playing that screaming sound. The next is our has played variable. Bool has played keeps us from being able to spam the jump scare if we happen to press the button more than once while it's still playing. In our start method, we grab a reference to our audio source so we can play it when we want to. Our play method primarily handles starting our coroutine, which is play sequence. Play sequence is going to turn on our jump scare visual. It's then going to transform it to make sure it's in the right location. Remember, when we're dealing with a 2D scene, the location of a game object in the hierarchy determines what it's in front of. So we make sure it's the very last element so it pops up on front of the screen. We play our audio source, we go ahead and trigger our camera shaking, and then we enter into our for loop based upon how many times we want this to occur. And then for every single texture in our texture 2D array, we iterate it over it, pausing based upon that frame rate, and then we swap it out. And this makes it look like we're going through our entire animation. Make sure you assign all the references you need in your inspector for your animatronic. Specifically, that raw image needs a link to the actual raw image object. You also need to drag and drop all of your texture 2Ds into that texture 2D array. You don't have to do this manually one after the other. You can drag all the images and then drag it over to that object and let go, and it will load them all up in sequence for you. For now, to trigger a jump scare, we're going to be using a button in the upper left-hand corner. This way you can press it and test out if your animation works without having to wait for any game logic to happen. In a future video, we'll come back to this and actually implement it within our game logic so that the game will end when a jump scare occurs. Go ahead and add a play button to your canvas and call it button_jumpscare and change the text to Foxy. In the on-click region of the button component, click the plus button. Drag your JS_Foxy game object into the reference and choose the play method that we created. Go ahead and deactivate the visual game object so the animatronic isn't visible when we start the game, adding an iconic scream. I went ahead and screamed into my microphone for a bit. Remember, this audio effect is going to be the most jarring part of your jump scare, so make sure it's interesting and intense. I spent a little time in Adobe Audition, tweaking the pitch and the timing, and then overlaying a few different clips until I got something that I thought sounded pretty crazy. Go ahead and drag and drop your audio file, whether that's a WAV or an MP3, into your audio folder. Now you need to drag your audio asset, either as a WAV or an MP3 object, into your project folder. Go ahead and add a new audio source component to your Jumpscare Foxy game object and drag and drop your sound onto it. With the way the script is currently set up, it will automatically grab a reference to that audio source so long as it has an audio source component attached, so you shouldn't have to do anything else. For your audio source, you want to make sure you turn off Play on Awake so we don't have that screaming sound effect happen as soon as the game starts. Okay, so we've got our scream recorded and tied to our audio source, but we need more. In the original Five Nights at Freddy's games, when the animatronic attacks, not only does it leap out at you and an audio source plays, but the entire background usually shakes if it appears like it's grabbing you. We're going to recreate that same effect by animating our background image to shake violently by using Translate, Rotate, and Scale. And the great thing is we can control this entire animation inside of Unity using the animator. First, I'm going to select the raw image in our canvas that holds our background view, the one we switch out whenever the camera changes camera feeds. With that selected, I'll open the animation window from Window, Animation, and then Animation again. I will then create a new clip. I'm going to call this Shake and Rotate. We'll keyframe the anchored position and the rotation and the scale of the background rect transform. I'll turn on the record button so we don't have to bother with keyframes too much. Now this part is all up to you. I suggest scaling up the image so we have some room to move and rotate the background. Then skip every 10 frames or so and move or rotate the background. You may need to watch your animatronic playing a few times to synchronize the feel. We're not trying to be precise here. We want this to be chaotic. Now I'll go over to the animator window and wire this up properly. We need to create an empty state which I'll rename to be idle. Set this as the default and then build a transition from idle to shake and rotate, and then back again. We're going to control the transition using a trigger parameter called shake that we'll create. If you name the parameter to be shake, then the code will automatically fire the shake effect using the background animator.setTrigger shake command. Let's go ahead, press play, and see what we made. We ended up with an unassigned reference exception, and this is because we jumped ahead and did not provide a reference to the background in the script we just created. Go ahead and drag and drop your background onto the camera shake variable in our jump scare sequence script. Alright, that was a lot of fun. Now we're going to dive into the version most of you are probably going to use, and that's using the Sprite method, creating the Sprite-based animated jump scare. Let's walk through the second method now, animating a cut-up image inside of Unity using pivots and the built-in animator. This method is nice because you don't need 3D renders. And if you create every animatronic to follow a similar format to what you do here, you can start swapping in different animations and even different body parts to create all kinds of Frankenstein-like animatronics. Let's now talk about our Sprite import settings. Select the image you imported and look in the inspector. Make sure you have set the texture type to Sprite this time, and the Sprite mode to multiple if you plan on cutting up your drawing into different individual parts. Click on the Sprite Editor button and use the automatic mode to create each separate sprite. You'll now need to tweak the boundaries of each sprite individually by dragging and clicking on them. Make sure you rename every single sprite appropriately so you can easily reference them later. Under your existing canvas, create a new image, but remove the image component. We are doing this to create a root game object that controls everything. The actual visuals will be under a child object, which I called waste, but I probably should have named it something like visual. I named mine thinrabbit_Georgie_JS so that I would remember it's my son's version and it's a jump scare. Remember, we will be working with image components from here on out, not raw images, because we're working specifically with sprites. Depending upon how many pieces you cut up your drawing into, you may have more or less child objects than I have. I organized mine so that I had the root or waist at the top. Under that are the legs and the midsection, followed by the torso and arms, then the head, and then finally the jaw. You will probably need to play around with where the pieces are located based on how you drew your animatronic. Don't be afraid to reorganize your elements if something looks off. I did this hierarchy so that the arms and head would move along with the torso when they were animated. Also, please take time to adjust the pivots of each of your parts. This will make your life a lot easier. You want to put the pivots in places that are easy to animate for you. So for arms, put them at the joints. For the jaw, place it at the top. Adjust the pivots using the pivot element in the transform. The values range between 0 and 1. Now is both the most fun and frustrating part, where you get to animate and bring your character to life. If this is your first time, don't be too hard on yourself. Animation is an art form and takes a lot of time to get right. For now, just focus on roughing something in. You can always come back later and adjust the animations. Even a silly flailing animatronic is going to look really scary when you couple it with your sound effect and it popping up out of nowhere spontaneously. With the root game object selected and the animation panel open, go ahead and create a new animator controller called thinrabbit_JS, or whatever your animatronic happens to be called. Go ahead and press the record button in the upper left-hand corner and start selecting the different parts of your animatronic. With the record button being pressed, when you translate, rotate, or scale each part, keyframes will automatically be added. I ended up manipulating the scale to make it seem like the entire animatronic was coming out at you. I then used rotations for all the different body parts. For the jaw, I ended up translating it up and down to make it look like it was biting the player. I did have to go back multiple times and revise my artwork. Every time that I would move a limb a little bit too far, I would notice gaps or missing pieces in the drawing. If something doesn't work out, just jump back into whatever your image editing program was and add those elements that you're missing. A lot of times this can be fixed by just adding a little extra background behind the joint. Now it's time to jump into the animator window and wire this up properly. We need to create an empty state, which I'll rename to be idle, and set that as the default state. And then build a transition from idle to thinrabbit_jumpscare, our animation we just created, and then back again. Go over to the parameters window and create a new trigger called Jumpscare. This is what we're going to use to fire off our animation in code. Now it's time for us to create our script that's going to make this jump scare fire off. We're going to do that by attaching it to our jump scare game object. Let's review this script very briefly. We have two public references that we need to make sure we attach in this script. The first is a reference to the background, our camera shake that we set up earlier in this video. Next is a reference to the visual element of our puppet so we can turn it on and off. Next we have a reference to our animator and audio source so we can control when the animation begins as well as when audio plays. Our start method is responsible for grabbing references to both the audio source and the animator. Make sure you attach audio sources and animators to this game object so it functions. Next we have our play method, which is responsible for starting our coroutine. The play sequence method does the heavy work in the system. It turns on the visuals, makes sure that the audio source and triggers are set, and then it yields and waits 1 frame so that the animator's state is updated. We then get the current length of the animation state and then wait until the animation is completed before finally turning off the visual. Remember to add all the missing references before you try to run this scene. If you skip past the first half of this video, you missed the part about adding an audio source and animating the background to shake. We'll now add an audio source to our game object and attach our scream sound. Make sure you also attach the camera shake animator reference here. For your button, in the on-click section, go ahead and drag and drop your jump scare animatronic. And make sure you assign the play method to get fired whenever that button is pressed. And now it's time to test things out. Go ahead and hit the play button and watch what happens. You now have 2 entirely different ways of doing jump scares inside of your game, either using pre-rendered graphics or created using your own drawings in Sprite sheets. But ultimately, regardless of what style you use, they're all going to be pretty scary. But there's still a lot more left to do in this series. In the next video, we need to do some house cleaning. We need to integrate some of these different parts that we've kind of left dangling and by themselves. Specifically, we need to actually kill the player at the end of the animatronic jump scare. So we need to set up our logic, fade the game out, and tell them that they died and then restart the whole thing. And then there's the important part about resetting the camera background. Right now, as you move through your map from the previous video, you'll notice that we never go back to the control room. We'll be fixing that in the next video as well. If you're enjoying the series, please consider subscribing and hit the like button below. Remember that all of the code from this series is available for free on my website at gleecakes.com. And if you're a Patreon supporter at the creative level, you get access to all the assets I show in these videos. I'll see you all in the next video where we make death a little bit more permanent. So long and goodbye. I want to thank all my subscribers out there, but especially my creator tier Patreon members. You're the reason I continue to make these videos, and your support really helps.